Hi, are you planning to master Amazon EKS service or just getting started to learn containers and Kubernetes? If the answer is yes, you're in the right place. This is a multi-part Amazon EKS deep dive series where we will cover various aspects of running workloads on Amazon EKS. Let's get started.
Welcome to the module Introduction to Amazon EKS. In this module, you will learn the following topics. Identify the purpose of Amazon Elastic Kubernetes Service. Recognize what problems does Amazon EKS solve. Identify the key benefits of Amazon EKS. Recognize the key characteristics of Amazon EKS. Also, the wide range of use cases supported. You will learn why many AWS customers run Kubernetes on Amazon EKS. We will discuss access to the vast ecosystem that is the Cloud Native Computing Foundation (CNCF). Amazon Elastic Kubernetes Service is a managed container orchestration service. Amazon EKS facilitates deploying, managing, and scaling Kubernetes applications both in the AWS cloud or on premises. Amazon EKS helps you to provide highly available and secure clusters. Amazon EKS also helps you to automate key tasks such as patching, node provisioning, and updates. Amazon EKS streamlines running Kubernetes on Amazon Web Services. Amazon EKS handles many undifferentiated heavy lifting tasks such as the following. Complete Kubernetes control plane lifecycle management, which includes continuous health monitoring of control plane nodes and replacement. Automatic scaling of control plane without any need for the support ticket. Use blue-green strategy to update the control plane. Automatic backup and restore of etcd database. Apart from control plane, Amazon EKS also handles data plane and add-ons management. So all of these capabilities allows customers to focus on building and running applications instead of managing infrastructure. Customers are exponentially using cloud native technologies and development teams, running microservices and running container workloads. Kubernetes is becoming a popular choice and de facto standard for deploying cloud native applications. There is tremendous growth in Kubernetes in the last few years. One of the biggest factor for the growth is due to the vibrant community and vast ecosystem around Kubernetes. There are many large enterprises, startups, and even students all contributing to the open source community and fueling the growth of the entire landscape. Kubernetes is managed by the Cloud Native Computing Foundation, which has a lot of different projects well integrated into Kubernetes. The CNCF includes hundreds of open source projects. One of them is Helm. Helm is a package manager which makes it easy to find a library to use in my application that is packaged in a Helm chart. You can also deploy capabilities such as service meshes for applications that want to communicate with each other across network boundaries. You can deploy DevOps tools such as Argo CD and Flux to implement GitOps patterns. You can also deploy observability tools, streaming platforms, and even databases and different stateful workloads on Kubernetes. So Kubernetes has become a general purpose platform to host variety of workloads in an organization. Kubernetes can be deployed in a lot of different places such as different clouds, on premises, edge, and hybrid. Customers love that flexibility and choice. Hence, a lot of customers run Kubernetes in AWS. Amazon EKS is the most preferred and best option for customers to run containerized workloads. Self-managed Kubernetes will be very challenging for customers. They deploy Kubernetes on Amazon EC2. They were spending most of the time and struggling with managing the control plane. That includes making it resilient, secure, and working with different networks. Amazon EKS is well integrated with native AWS services, making use of AWS security. The other thing is customers can build different types of applications, including microservices or migrating monolith from on-premises. Amazon EKS customers can leverage different machine architectures on AWS, including Intel and Graviton. There are more than 800 permutations of various machine types, generations, sizes, and architectures. Carpenter is an open source project that's contributed to the CNCF. It dynamically launches right-sized Amazon EC2 instances to support different workloads. They can include compute intensive, general purpose, memory intensive, GPU, or generative AI workloads. Beyond taking care of undifferentiated heavy lifting, Amazon EKS has been instrumental for many customers across different verticals such as healthcare, life sciences, or automotive or retail. Amazon EKS enables diverse set of use cases such as financial applications, financial modeling, claims processing, life sciences and e-commerce across startups and large enterprises. There are different persona working on Kubernetes, including developers who are building and deploying applications. There's a lot different categories of teams, such as platform engineers or site reliability engineers or DevOps teams that manage clusters, upgrade clusters, run clusters, secure them, and takes care of observability monitoring. So it's very important to understand and implement various best practices around 5 high-level domains, such as 1. Cluster design, 2. Networking, 3. Security, 4. DevOps, and 5. Observability. AWS will use commercially reasonable efforts to ensure that the service level agreements for Amazon EKS, that is to keep the Kubernetes endpoint for an Amazon EKS cluster available with a monthly uptime of at least 99.95%. This will translate to an yearly downtime of 4 hours, 22 minutes, and 58 seconds. The Amazon EKS control plane consists of at least 2 API server nodes and 3 etcd nodes across 3 availability zones at any given point in time for high availability. Amazon EKS automatically detects and replaces unhealthy control plane nodes, which removes a significant operational burden for running Kubernetes. So with this capability, you can focus on building your applications instead of managing AWS infrastructure. To get started with Amazon EKS, you provision your cluster of worker nodes. Amazon EKS handles the provisioning, scaling, and management of the Kubernetes control plane in a highly available and secure configuration. You then connect to the Amazon EKS cluster using the graphical or command line interface. After you've connected to the Amazon EKS cluster, you're ready to deploy your Kubernetes applications to your Amazon EKS cluster using standard tools. You can do this the same way that you would with any other Kubernetes environment. Amazon EKS provides a managed Kubernetes service that integrates with other AWS services. You get a standardized way to deploy, manage, and scale containerized applications using Kubernetes, whether you run microservices, batch processing jobs, or machine learning workloads. Amazon EKS streamlines the use of Kubernetes on AWS and gives you the power of container orchestration without the complexity of managing Kubernetes clusters. Sometimes it will be confusing while working with two separate APIs, and their respective tools adds complexity to managing your environment when getting started with Amazon EKS. So let's understand the difference between these two APIs. You use the Amazon EKS API for anything that Amazon EKS manages. This includes the entire control plane, creating and managing the cluster. Amazon EKS can also manage parts of the data plane using features such as managed node groups and AWS Fargate. You will need to authenticate and authorize with AWS Identity and Access Management Service. You can use tools like AWS Command Line Interface or EKSCTL to manage Amazon EKS cluster. Here are some of the example commands. You use the Kubernetes API for managing the lifecycle of Kubernetes objects such as pods, deployments, and namespaces. You need to authenticate with Kubernetes API server and authorize with RBAC. You can use tools like kubectl to manage the Kubernetes objects lifecycle. Here are some of the example commands. Amazon EKS addresses many challenges. Amazon EKS handles Kubernetes complexity because setting up and managing Kubernetes clusters can be intricate and require specialized expertise. Provisioning and maintaining infrastructure for Kubernetes clusters can be resource intensive. Scaling Kubernetes clusters manually to meet varying workload demands can be difficult. Making sure there is high availability and fault tolerance for Kubernetes clusters can be challenging. Managing costs associated with running Kubernetes clusters can be complex. Maintaining secure and compliant Kubernetes environments requires continuous effort and monitoring. Amazon EKS offers a managed control plane for Kubernetes clusters. This service takes care of setup, management, and maintenance tasks so you can concentrate on building and deploying applications. To reduce operational overhead, Amazon EKS streamline Kubernetes operations with features such as automatic updates, scaling, and monitoring. Amazon EKS uses the AWS scalable and highly available infrastructure, which provides resilience and performance for your workloads. Amazon EKS integrates seamlessly with other AWS services for a secure and compliant environment. Amazon EKS is certified by multiple compliance programs for regulate and sensitive applications. It is compliant with the following: Security Operations Center, SOC, Payment Card Industry, PCI, International Organization for Standardization, ISO, Federal Risk and Authorization Management Program, FedRAMP, Information Security, Registered Assessors Program, IRAP, Cloud Computing Compliance Controls Catalog, C5. You can use Amazon EKS anywhere to create and operate Kubernetes clusters on premises, which facilitates hybrid cloud strategies. You can run nodes on AWS hosted infrastructure in AWS regions, AWS local zones, and AWS wavelength zones. You can also run nodes in your on premises environments with AWS Outposts and Amazon EKS hybrid nodes. Amazon EKS actively participates in and supports the open source Kubernetes community. It uses Amazon EKS distro, a Kubernetes distribution based on open source components, and provides tools like EKSCTL to simplify cluster management. EKS also offers a catalog of community add-ons, including popular open source Kubernetes tools. Amazon EKS runs and scales the Kubernetes control plane across multiple AWS availability zones to ensure high availability. This control plane consists of at least 2 API server instances and 3 etcd instances that run across 3 availability zones within an AWS region. Amazon EKS is certified to be compliant with upstream Kubernetes. This means that EKS runs the same Kubernetes version as the open source Kubernetes community and supports the same APIs, tooling, and plugins. EKS is built on top of the open source Kubernetes project, meaning it uses the same core Kubernetes components and APIs that are used by other Kubernetes distributions and environments. The conformance means you can easily migrate your existing Kubernetes applications to EKS, take advantage of the Kubernetes community ecosystem, and leverage the same tools and plugins you are already familiar with. Let us summarize what we learned so far in this module, Introduction to Amazon EKS. Amazon EKS offers fully managed K8s control plane and parts of data plane and add-on management with high availability. Amazon EKS is certified to be compliant with upstream Kubernetes. Amazon EKS is very well integrated with many native AWS services for operations and security. Amazon EKS runs the same Kubernetes version as the open source Kubernetes community and supports the same APIs, tooling, and plugins. Amazon EKS supports broad spectrum of use case, making it a popular choice for standardization of internal platforms. Finally, Amazon EKS is built based vast experience of running and operating thousands of production grade Kubernetes clusters. It is built based on the well architected framework. As we always say, there is no compression algorithm for experience.